And imagine you are at a restaurant, you have to make a payment, but the application keeps on declining your payment, assuming it's fraud. Whenever you present any project in an interview, one of the most important questions they're going to ask you is, so accuracy is not always a good measure when your data is highly imbalanced. And the reason is, so now that we are done with the accuracy part, let's understand precision. Precision is going to help you with the correct, but you want to find a balance of both of them, which is where the F1 score comes into picture. From 61%, 62% has increased to 98% model performance. So this is where you want to talk about model optimization. Hey everyone, welcome back to the channel. My name is Anuj, and in today's video, I'm going to help you with the third part of the UPI Fraud Detection Project using machine learning. Part 1 and Part 2 are already out on my channel, so if you have not watched those videos already, please do check them out. I'm going to help you with a quick recap very quickly. So in the Part 1 of this project, we have helped with data cleaning. We have covered data understanding and data manipulation using libraries like pandas, and we have used different functions, and we have also worked upon handling missing values and handling duplicate values and so on. So that part mostly focuses upon using pandas in different functions to perform data manipulation techniques. In the second part of the video, we have focused mostly on data visualization. We have also covered exploratory data analysis and publishing the key insights for our stakeholders. So if you want to focus on that, the second part of the video is the one that you want to watch. In today's video, we are going to cover some very important topics, which are really going to be focused upon model building. So I'm going to help you with how do you prepare your data for model building. I'm going to help you understand how do you select the right models of your choice for the project, and what are the data balancing techniques. How can you use those techniques to balance the data in case your data set is highly imbalanced? And lastly, I'm going to help you with model evaluation with the right matrices, and finally model optimization using different techniques. So without any further delays, let's get started. All right guys, so I hope you can see my screen very well now. So I'm going to cover the agenda for this video. So we are going to start with dropping the unnecessary columns, as you can see, which is going to streamline our data set for the best performance. Next, we are going to talk about data pre-processing, and this will include your encoding and scaling techniques, which by the way, I have already covered these two techniques in a separate video, so you can do check them out. Next, I'm going to help you with the model selection bit. In this project, we are going to focus on binary class classification. So I'm going to use these particular models, and I will tell you why these models have been used. Okay. And then I'm going to talk about the performance matrices and how do we interpret them. Okay. So I'm going to talk about this in more detail, so don't worry. And then I'm going to show you what are the different techniques for data balancing and what technique I have used in our project, which is the SMOTE. And I'm going to compare the results post and pre data balancing, so we can see what difference does it make when it comes to data balancing techniques. And finally, I'm going to help you with the model optimization techniques, which is going to include your hyperparameter tuning. Okay. And finally, I'm going to help you understand what is the best performing model, and finally, how do you save the respective model. So that being said, I hope it gives you a clear idea about what to expect from this video. So stay tuned till the end, and I'm going to help you with the code right away. All right, guys, so I hope you can see my screen correctly. And in the previous part of the video, we have already covered the data visualization part, which is until this part. And here are some insights from the visualization. So these are called the key insights or actionable insights, which you will be providing to your stakeholders so that they can make informed decisions about the business and the problem. So you can just go through it. For now, you can just take a snippet. I hope you are able to see them now. Okay, so let's proceed towards the remaining part of the video. So the first step is going to be dropping the unnecessary columns. This process is going to streamline your data set so that we can build our data set and prepare it for model building step. The first thing you want to do is you want to drop columns which are not adding much value to your data analysis. Primarily any value or any column that has a lot of unique values is not going to help you in the data analysis process. Okay, so since I've already extracted the month and the year part, so I'm removing the date column. Time is not so important for me, so I'm removing it. Day since last transaction, transaction status, device operating system, the channel and the transaction city. These are going to be, some columns which have a lot of unique values. That is why I'm removing it. Once I'm done with it, I have the updated data frame, which only has up to 8 features or 8 columns to deal with. Right, guys, so as you can see, we have only 8 features available after this one, and we have 50,000 rows of data. Next, we are going to perform is the data pre-processing steps, and the two most important steps are the encoding and the scaling bit. I've already made videos about encoding and scaling in data pre-processing videos. So if you have not watched this video in detail, or if you want to learn the encoding and scaling in a bit more detail, so I recommend you check that video out. But essentially what I'm doing is I'm creating a copy of my data frame, okay, into this one. So it's a copied data that has same features and everything else, and I'm performing the encoding and scaling in this data. Okay, I'm basically converting my year into a category. Okay, so I'm correcting the data frames or data types. As you can see, year was a number, but I do not want to treat this as a number because year is basically a category for me. You cannot perform the aggregations like sum or multiply two different years. It doesn't make sense. So therefore, I'm converting this into the right data type. Now, the next step is extracting the categorical columns. Okay. Then what I'm doing is I'm importing the label encoder from the sklearn pre-processing library. Now I only have two ordinal variables here, which is the year and the month columns. Ordinal means it follows a natural order. So month column follows a natural order like January, February, March, and so on. Year column follows a natural order like 2021, 22, 23, 24, so on. Okay, so these two columns are primarily your ordinal variables. So I'm extracting these two and I'm initializing my label encoder and I'm performing fit underscore transform for these specific variables. Okay, so now these two particular variables will be encoded using label encoder because these are ordinal variables. Now for the other variables in my dataset, I'm going to extract them in a different variable called non-ordinal variables, which are these. Once I'm done with this one, so for these non-ordinal variables, you want to use something called one-hot encoding. Okay, again, if you have not watched the video, data pre-processing, we'll talk about encoding and scaling. Now, once your data is converted or encoded with the help of one-hot encoding, sometimes you might want to get you might get like zeros and ones, or sometimes you might get true and false. To avoid getting true and false in your matrix, I'm basically converting the entire encoded data as an integer. So when that happens, I will get a matrix like this. So my data will be updated. Now it has 54 columns and 5 rows. Okay, so basically what's happening, I mean, I'm just checking 5 rows, but essentially, as you can see, what's happening is every single variable is now numeric in nature. I do not have any kind of categorical variable because your machine does not understand any kind of, you can say, categorical variable. It only understands numbers. So it's an important part of the data pre-processing. Once you're done with this one, you can check with the data types. Everything is an integer, which is good to go. Next, we have checked that now is earlier we had 8 features, now we have 54, but now it's an optional step. What I've done is to improve the computational efficiency. Okay, I've just taken 50% of the entire data for model building. Okay, so basically what I'm trying to do is I'm just taking a sample of the entire data and trying to build my model, because when you will be, I will talk about why exactly I'm doing this, just to save some resources in case uh, your laptop or your computer is not very powerful. So when you're working with data, sometimes it can be very demanding. Okay, so to save yourself some computational power and some computational efficiency, what you can do, you can take a sample of the data that has same characteristics and build your model. Okay, and that way you can mimic how you can build a model without having to work on the entire data set. Okay, so I have imported train test split. Okay, I've taken the fraud data into this variable, non-fraud data into this variable. Okay, then what I'm doing is I'm taking a sample data. That means I'm taking 50% of fraud data 50% of non-fraud data, and I'm concatenating them. This way, what happens? I'm taking non-fraud data 50%, fraud data 50%. So when you combine both the data sets, the target value distribution will range. So if you recall, when we actually were building our model, okay, so the original data set had the target value distribution as fraud data 1.5%, non-fraud data the remaining percent, right? Approximately 97% something. So this was the original distribution, and I had 50,000 rows of data. Now what happened? I just took 50% of this, 50% of this, and I combined it. Now the ratio is still the same, but the amount of data is basically 50%. Okay, in the model building, what we are doing is we have first of all made a function. This function is going to perform the pre-processing. So we are already done with the encoding part. Now we are going to do the scaling part. To perform the scaling, what I'm doing is I'm initializing my standard scaler, which is available under pre-processing sklearn library. I've initialized standard scaler. Okay, I've applied fit underscore transform for all the inputs, and I'm returning the output as input scaled variables. Now, basically what I'm doing is I'm making my x and y. X is going to be your independent variables. So my target value is fraud. So I've removed the fraud column here. And once I've got the x and y, I'm applying this entire function of pre-processing or scaling only to the input features. Scaling is only done to the input features, not to the output variable. I've got the input scale features. Okay, now what I want to do, I want to apply a train test split. Okay, train test split, in case you're not aware of it, what happens is you want to split your data into two different parts. One set is going to be your training data, the other set is going to be your testing data, and that is going to help you so that you do not just have only training predictions, but you can also kind of test your model on unseen data. This is going to be your test data. In this case, I'm taking only 20% as test size, 80% as your training data. Random state essentially means that the model will perform exactly the same, will produce the same results every single time I run this. So random state is optional, but as you can see, after the train test bit, essentially I had 50,000 rows. After doing the 50% of the data, I had 25,000 rows, out of which it has taken 20,000 training, 5,000 test. Okay, in this section, what I'm doing is I'm importing different matrices to measure the performance, which is available under sklearn.metrics. Next, I'm importing these models. Now, these models are going to play a very important role. So, what models are suitable for your respective choice? In this case, because I'm trying to predict either fraud or non-fraud, which means it's a binary classification, yes or no. In that case, I want a classification model. So the traditional model is decision tree. Then I have an advanced model, which is your random forest classifier. This is quite advanced. Then I have taken gradient boosting, and the final one is extreme version of gradient boosting. So these three algorithms, as you can see, these are very common and popular now because these are getting matured now. So I've used them. Now what you can see is, now when I'm doing the train test split, what I'm doing is I'm also performing stratified sampling, which means when I'm doing 20% test size, 80% of training data, I'm ensuring that my distribution of target variable remains same. So in case I have 1.5% fraud data, 97% data as non-fraud. So when I'm taking samples from training and test, I want to ensure that the fraud samples are same in both these sets, training as well as test. Why is it important? Because if you just take 20% of your entire data as test data, it might be a possibility that in your test data there is no fraud data available, right? There is no fraud data because majority of your data contains non-fraud transactions only. So if I have 25,000 rows and I just take 20% of that, there is a possibility that I will only contain the non-fraud transactions, which are meaningless because in my test data there is no fraud data. Okay, so my model will get biased. To avoid that bias, what I'm doing is that in my test data, I'm maintaining the same percentage of the target variable. So in my training data, I will have 1.5% fraud. test data 1.5% fraud. That's the idea of stratified sampling. So if you want to read more about stratified sampling, you can just read about it or Google about it. Okay, so it will show you some samples that will really help you explain that. I'm not going to go into that detail, so I'm skipping that part right now. But hopefully you got some idea. Okay, so this is where I'm doing the split. Okay, maintaining the target value distribution. Now, so once your data samples have been collected, now the next thing that you want to do is I have made this function that takes a model, and from your test data it takes the input and the output. Now when you are applying the model.predict, it's basically taking the test input and saving the output as the y underscore predicted value. Now when you want to compute the output, so basically what you're doing is you are taking the actual output and comparing it with your predictions. Now you want to see how many predictions are correct, how many predictions are not correct. Basis that you will find out the accuracy, precision, recall, F1 score, and ROC underscore AUC. Now these are your computational matrices. Whenever you present any project in an interview, one of the most important questions they're going to ask you is, what are the evaluation matrices that you have used? Why have you used those matrices here? Okay, so this is an important question that every interviewer will ask you. So you want to ensure that you do have some good understanding for it. Okay, in case you do have any kind of confusion, it's always a good idea to please read about the matrices. So I'm going to walk you through with these matrices first. Okay, let's talk about accuracy. So accuracy represents the overall correctness of the model, but it can be misleading when your data is highly imbalanced. So accuracy is not always a good measure when your data is highly imbalanced, and the reason is because my data has 97% data as non-fraud and only 1.5% data as fraud. So when it comes to accuracy score, if it's higher, there are chances that my model is more accurate when it comes to non-fraud predictions compared to fraud predictions, because that data is biased. That's why when the data is imbalanced, it is not a reliable metric. But for the sake of the model evaluation, I have kept it here so that I can show you why this is not reliable. So now that we are done with the accuracy part, let's understand precision. Precision is going to help you with the correctly predicted values as fraud. So in your data, how many fraud transactions have been correctly predicted? That is what precision represents. It also, higher precision value means that your model is not predicting non-fraud cases as fraud. And imagine you are at a restaurant and you have to make a payment, but the application keeps on declining your payment, assuming it's fraud, but it's not fraud. Okay, so in this case, the system is detecting incorrectly that your transaction is a fraud transaction, which is actually not a fraudulent transaction. This incident is basically your precision. Precision means I'm only trying to predict the actual fraud cases as fraud. So if my precision value is less, there are chances that I will basically have same situation wherein a customer is making a purchase and I will say it's a fraud transaction. Actually, this is not a fraud transaction. What happens in these cases? A bank might lose its customers because as a customer, I don't want to have a payment system that is not reliable. Because when I'm trying to, let's suppose, get myself fuel or I'm buying something, I'm expecting that I do not have to carry my wallet. So now let's talk about recall. In precision, we have learned that higher precision means we are able to correctly pick up on the fraud cases and we are not trying to basically decline a regular transaction. Okay. In recall, it's also called sensitivity score, which means that how many actual fraud cases have been identified. When there is an actual fraud transaction, your model is not approving that transaction. Okay, so higher recall score basically helps you to avoid a false negative. Okay, false negative is when actually it's a fraud transaction and your model thinks it's a regular transaction. Now when that happens, it might lead to a big, we can say, financial fraud. So as even if there is one fraud transaction approved by the system or by the bank in this case, in that case, it might lead to financial fraud for a customer. So recall is very critical. Precision is also helpful, but you want to find a balance of both of them, which is where the F1 score comes into picture. F1 score is basically a harmonic mean of precision and recall. So F1 score is going to help you when your data is highly imbalanced. And in this scenario, let's suppose fraud, your F1 score will help you to correctly identify as many fraud cases as possible and with less incorrect predictions to ensure that you're not losing the customers. Also, you're able to prevent fraud as much as possible. So I really hope you got the idea of this one. Finally, let's talk about ROC underscore AUC. All right, so now let's talk about ROC under AUC score. So this score basically is the model's ability to distinguish between fraud and non-fraud cases, and a higher score of ROC underscore AUC, which can be closer to 1, it means that it has a better performance. Your model is able to distinguish very well between fraud and non-fraud cases. This is your ROC underscore AUC score. I hope you got some idea, but you can read about these matrices in more detail if you want. Let's move on. All right, so now once you have made these computational matrices, the next step is going to be how do we create a dictionary to store this output? So now we have made a dictionary and I'm saving all these outputs for every single model because I have multiple models to deal with. Now, in terms of models, I'm defining each and every model because I have 4 models here. In realistic scenario, you will not have 3 to 4 models to work with. Every organization either works on 1 or 2 models, usually depending upon the kind of predictions that they are doing. So in this case, I'm just testing these 4 models. Ideally, they will use random forest or extreme gradient boosting. These are very popular when it comes to fraud detection. They are very good also. But for the sake of this project, I'm using 4 to show you the difference. So I'm initializing these models, saving it into a model dictionary, and storing the output as a result dictionary here. Now, what I'm doing is for every model present here, what I'm doing is I'm basically fitting my training data. Okay. So I'm applying this for my training data. I'm training my all the models on the training data, and then I'm basically testing the predictions on the test data, storing it in matrices, and then updating my list as an output. What I'm trying to do with this is I'm trying to convert this output as a data frame and then print the results for you. The output will look somewhat like this. This is your model score. For every model, you have accuracy, precision, recall, F1 score, ROC score. Now, as I told you, accuracy, as you can see, is very high for all these models. But as I've already told you, accuracy is not a reliable metric. Reason being, because when it comes to higher accuracy, this is towards the non-fraud cases because that's the majority of your data. That's why it's not reliable. Precision, as you can see, this should be higher. But as you can see, for decision tree, it's very less, 63%. Then we have random forest, which is good. Gradient boosting is good. XGBoost is good. Recall score, as you can see, is very less, close to 60%, so not very good. F1 score, which is going to be the evaluation metrics for our project. Let's see the scores here. 61%, not so good. 70% here, 66 and 68%, so not so good. Now ROC-AUC score, it has to be as close to 1 as possible. So the higher value, the better. So as you can see, the highest value is for extreme gradient boosting. Okay, so I've made some inferences for you. So I can make myself just a little bit smaller here for you. I hope it gives you a good understanding now. So because data imbalance is causing such an issue, so we are going to balance this data with the help of some techniques available. So there are some techniques available to balance the data. So I'm not going to cover everything, but usually you have undersampling technique, oversampling technique, and something called SMOTE technique. So these are some techniques which are used to kind of balance the data. So in this case, I'm not touching the inputs and outputs here. So the training and test data, as you can see here, I'm not going to touch that one. So what I'm doing here is I'm taking my X and Y once again. And as you can see, 53 rows, 25,000 is the overall value. For same for the output as well. Now under IMB learn, oversampling, we have available this SMOTE. So what I'm doing is I'm basically using this SMOTE function, and I'm using a function called fit underscore resample, and I'm applying my input and output. Okay, so for these two, it will basically compare the ratios and it will try to basically obtain the outputs in the same ratio. So initially, if the distribution was like 97% 1.5, now I'll show you when you print the output value, it will be same. So as it says, now your non-fraud value is 24,613. Fraud value is 24,613. Now what happened is your fraud values, non-fraud values are same. How did it achieve this? By duplicating the fraud values until it reaches the threshold, which is your non-fraud values. Now what I'm doing is I'm basically creating the same code. So it's the exact same code as previous one. When you run the results now, you will see some difference. So now when you see this, you will see that now accuracy is any which ways good. But when it comes to precision, from 61%, 62% has increased to 98%, 99, 98, 99, which is a very good sign for our model performance. Same thing when it comes to recall, the value has increased to 99, close to 99, 94, 99. F1 score, which is the primary evaluation metric for us, you can see that that score is close to 98, 99, 97, 99. Okay, ROC score, which is supposed to be as close to 1 as possible, you can see the maximum value you have got is for XGB classifier. So what you can see is extreme gradient boosting, which I have already told you is very popular when it comes to fraud detection, has performed really well in all these matrices compared to all these three models. Okay, now what I want to do is I'm comparing the output of these models with the help of bar graphs. So as you can see, F1 score is the only metric that I've used for comparing it, and as you can see, when I'm sorting it, the best score is XGB classifier. Okay, so as you can see, the model is already performing really well. Okay, but in some cases you want to fine tune the model performance. So this is where you want to talk about model optimization. So we have hyperparameter tuning. So every single model, okay, every model has its own hyperparameters. In the interest of time, I'm not going to dive much into details, but I will just give you a brief background. There are two techniques to perform hyperparameter tuning. You can either perform a randomized search CV, which is much better in terms of efficiency. It's faster compared to GridSearchCV, but this is going to give you the best results because it tries and tests every single combination available. Whereas in randomized search CV, it has random combinations of parameters wherein it tests the model performance. So basically what's happening when it comes to GridSearchCV, you're performing a grid of parameters. So for decision tree, you have these two parameters, maximum depth, minimum sample split. Same thing, random forest, you have got three hyperparameters here. This is where I provided a range of parameters here. Okay, gradient boosting, range of parameters, XGBoost, range of parameters. Now what's happening is I'm creating an empty dictionary, and for every item available here, I'm going to provide the model, the parameter grid, scoring with the help of F1, and I'm going to provide a cross validation. Okay, so cross validation is going to be the value or k-fold, which is 5. Okay, I'm going to train my training data and I'm going to obtain the best parameters for every model, print it as an output. So as you can see, I'm basically providing 5 times fold, or you can say cross validation, and then printing my results of best parameters for every model. As you can see, the best parameter for decision tree, random forest, gradient boosting, and XGBoost. These are your best parameters for these hyperparameters. Okay, to save myself some time, I've written that as a markdown, that these are the best parameters for these models. All right, so now that we have the best parameters available, we are running the exact same code, but now instead of providing these models, as you can see, instead of providing these models like here, okay, I'm providing the maximum depth values or hyperparameter values. Okay, or you don't have to do this, but I'm just showing you the performance after hyperparameter tuning for every model. But you already know the best model is this. XGBoost, so you only need to focus on this one. But just to show you, if you test all the models again after hyperparameter tuning, you will see that XGBoost still comes on top. Okay, the performance is still the best across all these models. And I'm going to show you with the help of bar graph once again. As you can see, XGBoost with the help of F1 score is the best performing model. Moving on to final conclusion. So I have concluded that XGBoost is the best performing model out of all these 4 models available. So I'm going to import it once again. And with the help of these hyperparameters, okay, I'm making a model and I'm applying my sampled input and output. So these are your balanced variables. Okay. When you apply your model, you can see this is the model, how it looks like. This is your final model. Okay. And you can see that there are a lot of parameters, but I've only applied some parameters like learning rate, as you can see, maximum depth, okay, number of estimators, okay, and so on. So you can see that these are the parameters I've provided, and that's why you can see these parameters here. Everything else is just 0 or not available. Now what you want to do, once you have made your you can say model, you want to save it for future deployment. So I already have all these processes saved into my machine learning model, but you might want to make an application. You might want to deploy this on cloud, or maybe you want to create an application, you want to make a robot or AI or something. In that, if you want to deploy this model, you need to have this model saved somewhere. So you can create a pickle file, which is available under pickle library. So you can provide a path where you want to save it, provide a name for it, provide the extension .pkl, and you can use the file extensions here, and you can save the model. And in terms of the project conclusion, I have just said that XGBoost has been the best performing model. My recommendations to the business for fraud detection and you can say for prevention, some suggestions that I have made here. So I'm just going to make myself smaller. You can take a screenshot and you can read about this. Okay. And when it comes to further deployment, there are different ways that you can kind of deploy this project. And I have made an application which is based on Streamlit, and it's based on this machine learning model. I've already uploaded a demo on my channel. You can take some inspiration, make your own projects, play around with it, make some adjustments, and let me know if you have any questions or any doubts. I really hope you enjoyed this, and I'm going to see you in the next video. Until then, thank you so much for watching.